All right, we're good. Okay, so I'm just gonna show everybody around, kind of just the basic pieces of the Unity engine.
Sorry to interrupt real quick. There's a problem with Unity when you stream it directly. It keeps going
Oh,
in and
oh,
out of
yep,
like the different
yep,
tabs.
yep.
Yeah.
You're right. I know exactly what you're talking about. Thank you for pointing that out. All right, there we go. That should be better. All right, cool. So first off, we can. So once you open it, you'll be greeted with a screen similar to this. If you're in a 2D game, it'll look probably just like this. If you're in 3D, it'll look something like this, where you're obviously in a 3D environment. So I guess I'll just go piece by piece with each like section of the screen here, and go over what each of those does. So first, one of the probably most like familiar parts for everybody will be the project screen, the project window, because it's essentially just a file system. As you can tell, it looks just like like Windows Explorer or Finder on Mac. It's literally just files full of things. It's great for project organization because you can just kind of visualize everything you're looking for. You can right click and then create, and then just basically choose any of these file types you want whenever you're working on your game, and you can just store them right here in your file explorer. I usually use mine for different folders. Like this one's for scenes. That's by default, by the way. This will come with one that says scenes. I like to specify. Usually, I'll have one for materials. Whenever you're making like colors and stuff. Here we go, materials. Like if you're making, as you can see, kind of down here on the bottom right, we've got this colorful little sphere that is kind of just rendering to show like texture. So I'll make one for like materials. I'll make one for scripts is one that I always will have regardless of the game. That just throw all my C# scripts in. But yeah, it's pretty simple to manage. You just it's basically solely there for project organization to keep things clean and tidy. And so that you can find, all of one type of thing that you're looking for in one place, like all scripts, all materials, all whatever. I guess just staying around here, we can go to the console, which is right next to... This is all by default, by the way. You can actually move these windows around into different areas, but that gets a little confusing, and it's kind of up to personal preference, but this is by default what you should see. So the console is exactly as it sounds. It's just a console that is mostly used just for printing out errors and debug messages. When you're using Unity, if you are if you have an error that keeps showing up, like a bug, like something that's not causing an error but is not working how you intended it to, it's often very useful in your scripts to write a debug.log message, which, for those that don't know, debug.log is a command that literally just prints a message out into this console. So you can just say debug.log, button pressed, and then it'll just, if you connect that method to something, whenever you press the button, it'll put in chat, or in this console, it'll say button pressed. So that's just kind of a way to literally, as the name implies, debug your game. And that's where stuff in this console shows up. Additionally, probably more importantly, as I briefly mentioned earlier, errors will show up here. You guys will probably, new people as well as kind of veterans of Unity will probably become accustomed to, or already accustomed to, the beautiful null reference exception error, which is a very common one. I struggled with that one a lot when I first started. But the errors will show up in here in red because they're very scary, which I think is why they were colored that way. The errors are a little bit hard to kind of understand, especially if you don't know what they are. Double clicking on them will open the line of code that caused the error in your Visual Studio, if it was a Visual Studio error, like in your script that caused the error. Otherwise, sometimes it's still caused by like an error in the engine, which might also open a script. It might not. It might be file related. I can't do an entire thing on error checking right now, though, especially with an empty project. But we can do something like that later. But errors and debug messages, and also warnings. Actually, you can see these 3 types right here. The little like speech bubble is a debug message, or just any type of message that you put in the console. It's completely fine. If a message is in there, it doesn't mean anything bad. It just is like, okay, this was intended. Just do what I'm told to do. The code is basically saying. And then the warnings, which I was about to talk about, are these triangle hazard signs. Warnings will appear in yellow, and they don't exactly mean that an error has occurred, but it's kind of telling you there's potential for an error to occur because of this, and this. Or it'll say something like, Unity doesn't expect this that is in your scene to be happening, so we're just letting you know that it's there, so if something's weird, it might be something to look into. But the warnings are good ways that Unity Engine just kind of reminds you whenever you might be doing something that it doesn't want you to, which is really helpful for especially new people. And then of course the errors are this red stop sign with the exclamation point looking thing, and this just kind of tells you how many of each you have, and you can also click on them to sort the console to only show that type of message. So currently, like if I had like a bunch of errors and a bunch of debug messages and a bunch of warnings, if I just wanted to see the errors, I could click this, and then it would only show me errors. You can also do error pause, which I think it should stop any errors. Yeah. It whenever an error occurs, stops the game. It pauses it entirely, so that you can just kind of tell, okay, this is exactly what's happening in the game right now because it's frozen, is exactly what caused, or where the error like has taken place. You can also kind of just search right here with this editor thing. You can kind of find different error-related things. Collapse should just hide most of all of the errors and stuff that are in there. And then clear, there's a couple different options for clear where you can clear the console. It's for clearing the console. It just gets rid of all the messages, error, warning, and debug messages. It'll get rid of all of them by clicking clear here. And then you can click this little drop down to specify, okay, I want it to clear every time I play, I want it to clear every time I build, and I want it to clear every time I recompile, whatever. I recommend you have all these on, by the way, especially if you don't know what's up. These should be on by default. They're very helpful, at least to me. It just kind of does some things. Like if you have an error in your script and you go and fix it, having clear on recompile would be really nice, because then it'll automatically recompile your script, and then it'll say, oh, the error's gone, we'll clear the console, and it won't show up again. Whereas if you didn't have that, you might not notice. So that's the console. We'll jump up here to the hierarchy, which is one of the main, I'd say these top 3 are the ones you'll be using like 70 to 80% of the time, if you're not coding. The hierarchy is a way that like you can, it's also kind of like the project management screen. It's a way that you can both kind of structure your project the way that you'd like, but also get like a list of everything that's in this current scene. Because Unity is divided up into different scenes. Each scene holds different objects, and the objects are the things that you see or interact with in the game. So the hierarchy is also a way that you can change parents. Unity has a like parent-child system where like something, for example, let's create a cube. So this cube is just currently just sitting here in the scene. It's got no parents or children. It's just sitting there. It probably looks weird because this is a 2D preset in Unity, so it normally would be probably a whitish color, but it probably just looks really weird because it's trying to render something that's Unity believes is 2D and 3D. But this cube is currently, it doesn't have any parents or children, but we can create like another. Let's just create a sphere. Now the sphere, you can see the cube the sphere is slightly to the right of the cube. It's indented, which indicates that it's a child of the cube. so that if you now have this cube, it kind of selects both of them, and if you move the cube around, it moves the children with it. It's a good way to sort of once again kind of a structure thing. So for example, say that we have a capsule, which a lot of people often use to represent a player. Say we have a capsule, and then this capsule has like this camera on it. We'll move the camera to be a child of the capsule, and say it's just got a camera on it, and then you're kind of like using that camera as the face of the capsule, and it's like in first person. It's a first person game. The camera is the screen that you can see, and you're looking around with this capsule. You want to be able to move everything at once. So like if you're looking around with the capsule, you want to be able to rotate the capsule around, and as you can see, it rotates the camera with it. And so that's another big benefit. It's just mainly for structure in your project, as well as being able to like combine things to all move and interact with each other at once. To create to make something a parent or a child is as easy as just moving it. So right now this main camera is a child of the capsule. To make it not a child of the capsule, we can just click it and drag it up to be on its own thing to where it's not indented. And then we can actually also make the capsule a child of the camera by just clicking on it and then dragging it onto the camera so that the main camera is highlighted. And then we let go, and then it just does that. So that's mostly the gist of your hierarchy. This is also you don't have to do it in this way, but the way that I learned, this is also where you usually are creating new things. Like you've seen me right click in this menu and then do like create cube like I just did. That's how that's how we usually do it. Or sorry, at least how I usually do it. But I'm pretty sure you can actually you can do it down here for most things as well. Up next we have the scene view, which is this window in the middle that is used for looking around and finding things. To look around in the scene view, you hover your mouse over it and then hold right click and then just drag, and that's how you look around. And then you can move around. It's kind of like a no clip sort of thing with WASD, and you can increase your speed. It sort of like accelerates you, so you get faster the longer that you do it. If you hold shift, you move faster than if you just hold W normally without shift. And then in the scene view, it's used, like I kind of mentioned, it's used mainly for looking around and seeing the things in your scene, seeing them be represented, rather than just like having to load the game every time and then look around in the game somehow. The scene allows you to just visually see everything, even things that are hidden from the game view. If you have a camera that's not supposed to see something. It also shows things like the camera, which doesn't really have any sort of physical in the game. If you were to look at a camera in the game, like through a camera, say that this camera right here was looking at another camera, you wouldn't see anything. So the scene view shows you where your cameras and stuff are as well. Clicking on things also, it highlights them to show you like their parenthood. For example, this camera is the parent of the capsule, so you see them both highlight. And then there's these little buttons up here that you can use to change, that's to manipulate things in the scene. So the view tool is kind of default. That's the one that you use to kind of just click and drag. It'll move you around in a bit of a different way than just the right click move around with WASD method. And then you have your move tool, which if you click on it and then click on an object, you can also click on it in the hierarchy, or you can click on it in the scene. With the move tool selected, you can use these little arrows to move things. This one moves up and down, this one moves left and right, and this one, or sorry, actually I believe it's this one moves left and right, and this one moves front and back. You can also click on these little boxes in between to move like 2 dimensions at a time instead of just one. So we can move front and back and left to right at the same time when we do this one, up and left to right sort of thing as well. Then we have the rotate tool. It works kind of similarly to the movement tool, except instead of moving things, it just rotates. But it has these multicolored circles around them which just are the dimensions on which you want to rotate. So you can move up and down. You can move kind of based on the sides, and you can move on like a horizontal sort of plane with that one as well. Then we have the scalar tool. It increases the scale of things based on these arrows. So you'll notice this. You'll notice because the camera is actually kind of not really represented by a physical object. It doesn't seem to be doing anything, but since the capsule is a child of the parent, or of the camera, sorry, you'll see that whenever we manipulate the scalar thing, it scales up this cylinder or this capsule to be either really, really stretchy or really, really short. The higher that we go, the scale is higher on that. What's the word? It's higher on that not plane, but axis. Yeah, it's higher on that axis. And then if we do it like this, it makes it wider on this axis and then wider on this axis. Or we can do the very middle and just stretch them all out at the same time, which will just make it grow evenly so that it maintains its shape, but the size increases or decreases. And then right here, this one is mainly used for UI related things, the rect tool. If we go to our scene and we click 2D, we can right click and then create a UI object over here, and we'll create, let's just create a canvas. So now we have a canvas, which is basically just a thing you can use to put UI on. We can use this rect tool to manipulate this canvas. Or sorry, actually I should probably create a panel. There we go. Here we go. Okay, panel, which is now a child of this canvas. You can move the panel around using this rect tool, just to manipulate, sort of like exactly how you'd kind of make a PowerPoint slide. Same idea, like moving text and images around in a PowerPoint slide. It works the same way here. Like I said, mainly kind of used for UI. I think you can kind of use it for other purposes. Why did that get big? I don't know what just happened there. It's strange. Let me reopen my window here. Hierarchy. Oh crap, I completely just messed up this whole thing. I don't even know what I did. Let me open up a new project really quick.
Layouts under window. There was a way to reset your thing, I think.
Oh, there is? Oh, my bad.
Yeah, layouts, the fourth option.
Previous? No.
Default.
Default.
It's the third one.
Yes, thank you. Oh, crap. Sorry. Window, layouts, default. Thank you. I actually did not know that because I usually try to keep my window like exactly the same, and I don't usually run into errors like that. So thank you. I appreciate that. Yeah, but like I said, you can just use this rect tool to manipulate UI and things like that. And then this transform tool kind of does a few of these at once. You can scale, you can move, and you can rotate all at once. Most of the time, I kind of just stick to the specific ones because I don't want to accidentally click something I don't want to click on when I'm working with this. But the transform tool is kind of just an all-in-one, which is really nice. There's a couple of these other things up here I'm not going to really go into because they're a little bit advanced. You won't need to use them, all the time. The main one I do want to point out though is this 2D thing. I've been transferring between 2D and 3D by clicking this, and it literally that's what it does. Is it changes the way that the scene view shows from 2D, like we can see the UI here, to 3D. So that's good. Also up here at the top we have a play and a pause button. This is for compiling and then running your game inside of Unity. So if we hit play, it won't really show anything because our camera isn't really looking at our camera's not looking at anything, and there's nothing in the scene. We can also pause it though, if for example something we're updating, or if something were moving and our camera was looking at it. If we were to pause, it basically stops time within the game. And is useful for debugging. As we kind of talked about earlier in this console, you can have it you can have error pause on, where it'll do this pause automatically whenever an error occurs. You can also stop playing the game by pressing the play button again. But yeah, whenever you're trying to test your game out just briefly without having to like completely compile and build it and then open it, and then you have all this like stuff saved on your computer that you didn't want, like an early build, you can easily just hit play, and then you can experience, for the most part, exactly how your game will play. There's a couple of differences that we'll probably get into in later tutorials. But yeah, so that's also encapsulates this game view right here, which is right next to the scene view, because they somewhat go hand in hand. And then our final little menu we're going to talk about for right now, of the main ones at least, is the inspector. The inspector shows all of the data that is related to a specific object. Oh wait, let me open that. So for example, let's go back to this cube. Really quick, actually, this up here, this check mark, is a little box. It's like a tick mark that like enables and disables the object. So if we go to our cube by double clicking on the cube, we can see that there's actually nothing here. We have some data on it, but we don't see it. But clicking this re-enables the cube, so it's there again. But yeah, whenever you select something in the inspector, because you'll notice, the hierarchy, you'll notice that whenever nothing's selected, the inspector doesn't display anything because it needs an object to look at. So if you click on something in the hierarchy, it'll show you all the data about that object. Most objects in Unity come with a transform, even empty ones, which an empty object is kind of self-explanatory. It holds nothing except for a transform data in like a name. A transform is basically just a way to determine how an object is oriented in the scene. This is usually with position and rotation and scale, which is what all of these little buttons up here do. So you can change exactly where something is. You can type in, like 0, 0, 0, and it'll reset it to that coordinate on this 3D plane to find this game object. But other than that, you'll notice it doesn't actually have anything. If I were to click off of it, these arrows, you don't see anything here because it's empty. There's nothing there other than this transform. But yeah, so even empty objects have transforms. Most Unity objects by default do, unless you explicitly remove them. You'll also notice we have like a mesh, which is graphic related. I won't go too in depth into that in this tutorial right now. But once again, we'll probably talk about those later. And a box collider, which is useful for like physics. It kind of tells you whenever this thing is near or touching something else. Which you can use to like trigger certain events in your game, as well as a material which is used to actually like render outright what color and like sheen and texture that this thing has on it. You'll notice by default it's white, like we were showing earlier in this material thing. And so yeah, you can actually add components as well by clicking add component, and you can choose a feature you want to add to this object. So for example, if we wanted to add like an audio listener, which is the way that Unity is able to tell like where sound is, we can just right click and add an audio listener onto it. There's not much reason to do that unless you have like a camera on it, but just as an example, you can add a lot of different things on here as well. You can even add like animations and such, which is very cool. I do want to actually do one more thing before I'm going to wrap up my part of this. It's just kind of important a little bit for beginners, just for kind of because most of the time whenever you test out your program or your game, you'll do this play button right here, and it'll load up the game window here in Unity. You can actually build your game into an executable file with file and build settings / build and run. You might want to do build settings first. With this screen, you can choose the platform that you want to build it on. Unity has a lot by default, especially if when you install that version of Unity, you're given the option to install build options for each of these. So you'll notice a lot of these are grayed out because this version of Unity I have only builds to Windows, Mac, and Linux. You can choose like the type. You can choose your like architecture here. You can choose if you want it to be a development build, which includes like a console in the bottom left for playtesting for the most part, and you can add in scenes up here that are relevant to your game. And then down here, if you click build, it will build it, and then you choose like a location on your computer that you want it to build to. It'll create a folder, and it'll have all of the data that Unity needs to run your game, as well as an executable titled after your game. And if you click it and run it, you'll have this game's window, probably by default in full screen. And so it's a way that like basically this is how whenever someone makes a game on Unity and then puts it on Steam, and you buy the game on Steam and you download it and you play it, you're basically playing the built version of that game. That's why you don't have to, that's why you don't open the game in Unity Engine and then hit play and then run here, because you can build the game. You can also choose build and run, which will get where it'll try to like get where it wants to build at, so it knows where to put the files, and then it will automatically run without you having to do anything. But yeah, I think with that, our sort of show me around Unity section is over, and I think now Tyler has, for the second half of this meeting, I think he has a example script and some sort of intro to C# scripting that he wants to show us all. So give it up for Tyler.
All right, thank you, Rain. But yep, everyone, like you were saying, I'm just gonna go through a simple demo with the C# script. Go ahead and share my screen here. Can everyone see my screen?
Yeah, I see it. Oh,
All right. Okay. All right, cool. Just always like to double check. So basically, what the scripts do, it's pretty much just applying logic to objects in your game almost always. So I'll just go ahead and start off by creating some simple 3D object like a cube. So that's now in the game right there. And so basically what you want to do if you want to apply a script to an object, one thing you can do is come down to the inspector menu and then go all the way to the bottom and click on add component, and then click on new script, and then you can name the script. And then for this script, I'm just going to show how we can have a script automate the movement of a cube. So I'll just call it move cube. And then for me, I had Visual Studio Code on my MacBook. That's the editor I'm going to be using to write this code in. But it should open in just a second here. Normally it'll like open on its own. It looks like it's just loading everything up here. If not, I'll manually open it. Oh, there we go. And then before I get started on writing that code, just a few things I think are important to point out. First off, C# is very similar to Java in a lot of ways, syntactically and logically. Like I can explain some of those things as I go on, but every script file has a class. This doesn't need main. It's actually deriving from a Unity class called mono behavior. And then you have to have your script derive from mono behavior if you want to apply it to an object. Like maybe you have a script that isn't working with objects in your scene, and then in that case you wouldn't need it, but in most cases you will be applying a script to an object in one way or another, so you would want mono behavior there. And then Unity automatically loads some methods in that are commonly used. Like we have start and update here, and as you can see, start basically just runs its code before the first frame update. Like basically, like right when you hit play, this is what executes. And then for update, that's just a script that's just a function that runs every frame and then runs the code within it every frame. As like this is where I'll be writing the movement for this cube because we want the cube to update with every frame that's rendered on the screen. And then lastly, they don't have it in here, but I think it's important to show y'all. So there's another method called awake, and awake is another Unity method. And basically, if you want it, it loads or it runs when the scene is loaded. So that can be good or bad depending on the kind of game you're making. It could be good if you want to load certain assets in before the game starts, like rendering purposes, but it can also be problematic if if you have multiple scripts that are running the awake method and they're like dependencies on assets that are being loaded in. Like if you try to access an asset before it's loaded in, you're gonna get some kind of exception, probably some kind of like null exception that might crash your game. So we definitely need to be cautious with that, but it can be useful in certain cases. And then as far as movement goes, pretty much any object, as you can see in the inspector, has a transform, and then they also have a world position, and those are all stored in vector threes. So like I don't know if any of you have taken linear algebra or any sort of physics class, but Unity uses vectors to store positions and like transformations on those vectors, and as like matrices and like matrix operations. And so like a common way to think about it is just like if you're declaring like a vector three, that's just like a 3D vector like x, y, and z, and then you can just call it like whatever. And then like similar to Java, all object variables are like declared on the heap, so you use new every time you instantiate one of these objects. And so you just say new vector three, and then you just give it an x, y, or z. And then there's a lot of different things you can do with this. Like, for the purposes of this video, like I'll just apply a move function down here. But I just wanted you all to see like this is really the basis for a lot of different like object interactions on Unity. Like for instance, if I wanted to access this cube's like rotation or like modify this cube's rotation like via a script, I would just like apply a vector three that tells this that tells Unity to rotate this object by whatever the positions are in this vector. Like if it was like 90 0 0, they'll just be like, hey, like rotate that object by 90 degrees along its axis, something like that. But so now we got on this project. Obviously, if we're applying the script to a object in the scene, we need to define that object, and that class is called game object. Oops, sorry, and I'll make it public. One thing you will notice is if you declare something public, you can manually assign it in the inspector here, and that's really convenient for a lot of different reasons. But one of the main ones is if you're trying to reuse a script a lot, it's much easier to keep track of like what objects that script is modifying if you can see it like in the script component section of the inspector instead of like having to open up the script and like manually change things all the time. And then I was alt cube, and then so I don't have to like declare on the stack like this because I'm not instantiating it. Like Unity's gonna do that in the back end because like I'm not like it's already like loaded in the scene, right? Like I'm just assigning this game object in code here to this game object in our scene. And so what we're gonna need to do is like I actually don't need start, so I'll just say nothing here for now. Like this would just be like well actually I will use this. For instance, if we want to like apply speed to an object, like I could say like load speed. So that's like the speed the object's going to be moving at. And then I can just say speed equals like, I don't know, 2.5. And then also another important thing with Unity is if you're declaring a float, you always need to type f at the end. And the reason for this is that for some reason within the C# compiler, I don't know why I was designed this way, but all floating point numbers are automatically treated as doubles. unless they're explicitly typecasted to floats. And this is just the way, like even if you declare it like as a float and you don't put this f here, the compiler will still treat it like a double, and then that can cause problems down the line of like data loss and stuff if it has to like convert it back to the other data type down the line. So always make sure to put f like at the end of your floats. And then so now an update, I want to get the transform of this cube. So I'll just say cube dot transform, and then Unity has a built-in function called translate. Uh, if you ever take an algebra, it's exactly like it sounds. You're translating like position on a graph, like however many units, or however many units of displacement you want. So it's kind of like, it's applying a displacement operation to this cube's transform. Uh, and there are multiple ways to do this. This is just one of the easier ways, in my opinion. But there's also a built-in function called move. You can apply velocity to an object like instantaneously if you wanted. But this is just one of the ways I first learned how to do it, and it's just easy to keep track of. And so there's a couple of ways we can define the variables in here. To start off, I'm going to explain the difference between some of the default vector3 values. So if I say vector3 dot up, that's the same thing as saying like 0, 1, 1. Oh, sorry, 0, 1, 0, like just applying a 1 to the y value. And then I could also say vector3 dot uh, forward, and that's just like a default 0, 0, 1, like applying 1 unit of displacement along the z-axis as the default value here. And then if you wanted to go backwards, you would just say negative vector3 dot forward. And then as I was doing for the y-axis, you would just say negative vector3 dot up. And then for x, it's if you're moving along the positive side of the x-axis, you'd say vector3 dot right, or if you're trying to move towards the left, the more negative side, you say vector3 dots, or sorry, negative vector3 dot right. But for now, you can also like manually supply a vector as an argument. So I'm going to go ahead and do that. So I'll just say new vector 3, and then I can, make whatever values I want. So I'll just make it 0, 0, 3. So that's going to move like 3 units per of like time. And then also to keep something to keep track of, like this makes this speed method here redundant. So it's important to keep track of how, like, so if I were to instantiate like this, it's really moving it at 3 times 2.5 units per second instead of just 3. So if I want it to only be 2.5, I would set this to 1. And then we also have to multiply this by time dot delta time. And then basically what this is that it's telling Unity to multiply the displacement by the amount of time between each frame. And so what that does is makes your translation frame rate independent. And that's really useful because if you only have this update function render the movement of your cube for every frame, it might, look very sluggish and blocky, especially if like your frame rate is like moving like up and down, because you almost never have a consistent frame rate like that. But this keeps your movement consistent by multiplying your movement by a constant, well, sorry, not constant variable, but it's constant across all of the Unity scripts. Like it's a built-in timer within Unity. That way, they all appear to be moving at a constant rate, regardless of the actual amount of frames that are being rendered on the screen. If that makes sense. And then that's it there. And then basically, all you have to do to compile your code is just make sure you save your changes and then go back to Unity. And then they'll automatically, Unity's compiler will automatically compile your scripts. And then if you want Oh, sorry. Transform is lowercase actually. Excuse me. Uh, One quick distinction between C Sharp and Java that I could point out real quick is that all like methods are like upper camel case, like they're capitalized for the first letter of every word, and but for like like not methods, but objects and variables, it's usually like lower camel case, like I wouldn't say like transform up would look like this, right? But that's just really sort of like the syntax of C sharp. And so now that since that's fixed to lowercase, that should compile over here like it's supposed to. Yep, it's like so that means it's happening the way it should be. And then yeah, you also get, all your typical compiler warnings and stuff down here. Uh, so okay, so cleared on its own, that meant, I resolved the error. Like the red ones are compiler errors, red exclamation point, and then you'll get a yellow like triangle warning if there's like a compiler warning. And then now with this cube, I can just go to the cube and then see that this game object is not set. And then I can simply just grab this cube and put it in there. And also I made speed public. So I can actually change speed. Like it'll be assigned to this, but if I wanted to do something else, I can just make it like 5 units. And then if when I run and hit play, it should be moving like away from me. The built-in uh like movement is in meters, so it should be moving away from or so it's actually moving around the X. But yeah, you can see it's moving like to my left here, but I can also modify the speed like as it's moving. Now it's 50. Speed up along with that. And so that's really it. And then one more quick thing, if I wanted to modify this more, I can actually like I could supply all three of these as individual variables. Like instead of, saying new vector3 0 0 1, I can have like a public x or public int x um y z, and then I can supply those in here, and then I can actually assign those over here if I want to have it move in multiple directions. What did I
You
do?
you accidentally wrote Publix instead of public.
Oops. So yeah, that'll do it. Yeah, again, just tell you the line. So it was on 12. Then yeah, that was on 12. So just wait for it to compile. It'll compile. Um, should be good now because I fixed that. Yeah, and then so now like I didn't assign it any values in here. So I like their default value is 0, so it's not gonna move it off. I don't give them anything. I say like 5, 10, like show like random stuff, and then see how it moves around like in the scene when I do that. Just wait for it to load here, and then like later on we'll go into more detailed stuff like applying gravity and like more like physics related like applications of scripts. I just wanted to show. Oh, it's actually moving kind of fast. There. I just wanted to show like how movement generally works. And then so now we can see it kind of moving up. It's moving up fast because obviously, the Y is like the highest value here. I can make it a -1, have it come back down. And then another thing to keep note of, like if I like in this session right here, any changes that I've made and then Spectre or the scene hierarchy will like revert to what they were before I hit play. So like all of these like XYZ variables here will go back to 0 as soon as I like hit the play button over there. But yeah, and then also the cube will go back to its original location down there. Just double click to get back to it. But yeah. Does anyone have any questions? That's pretty much all I had for this script portion. I guess no questions. Cool, cool. But yeah, yeah. This is really all I had for this portion. I'll hand it back over to you, Rand.
All right. Yeah, I think that's everything we had planned for this mission, or sorry, for this meeting. If anybody wants to stick around and chat or talk about any game related stuff they want to talk about, that's cool. But otherwise, everybody can head out. One other thing I do want to mention though is I believe we have a meeting scheduled for next Wednesday. That's not going to be a tutorial meeting. It's about the upcoming sort of like game jam practice and preparation session. I think that, yeah, I believe that's next Wednesday. And we're going to look into getting a place at MLC for that so that we can have it for in person for people that are interested in that. And also we can have it online so that anybody that can't make it in person can still participate. So if you're interested in learning how game jams work and want to maybe participate in like a miniature sort of like for fun game jam, if maybe you need a group or something, we can sort you into a group or something of that nature. If you want to work alone, that's completely fine. But it'll be a sort of test run game jam that I will say there's not any sort of prize, but it's leading up to a game jam we are actually doing later on for a prize. This one will go on for a week. We'll have a theme for you to choose from if you like want to have a theme to go by. And yeah, so our meeting next week will be kind of just introducing how we're going to be doing that. But otherwise, yeah, I don't have anything else. So anybody that wants to stick around, feel free. We'll chat for a bit. I'll be here till probably 9. So yeah, thank you guys for coming. I really appreciate it. I'm glad we got a good turnout on this first one.
And also, real quick, sorry to interrupt. Before you all leave, if you have not filled out the start of the year form, please do that. It's pinned in the announcements channel. It really just gives the officers a good idea of the level of experience the club members have with Unity, and also who is interested in what aspects of